Good day, everyone, and welcome to the latest in our series of webinars on innovative dairy solutions for a changing industry. And today our focus is going to be on homogenization and homogenizers. Thank you for being with us. My name is Con O'Driscoll, and I am a global product manager with SPX Flow, and my focus is on our dispersion products, which includes homogenizers, separators, and high-shear mixers. I'm based in the south of England, and I've been in this role for about 7 years. And before that, I worked in a variety of positions, including process engineering and application engineering. So my aim today is to take you through some information on how homogenizers are used in the dairy industry and share some insights on how you can improve your dairy operation by making some changes in your homogenizer selection or upgrading your existing homogenizer. And as we start, I'll share a few housekeeping notes. First of all, as an audience member, you will not have audio or video capability on this webinar, but you can use the Q&A feature of the webinar to submit any questions throughout the presentation, and I'll answer as many as I can as we reach the end part of the presentation. If we don't get enough time today to answer your questions, then you will have my contact details also at the end, and feel free to contact me should you wish to do so. Before we get into the presentation properly, just wanted to share a note on our latest impact report on sustainability. There are a lot of details on this slide, but to summarize, our team is committed to sustainable solutions that positively impact our communities. We've shared a lot of these solutions in our impact report. My colleagues will share the link to that report now, should you wish to do so. One highlight that we call out is that about 50% of our 460 or so patents encompass sustainable and clean technologies. So this is something that's part of our everyday life as we engineer and develop new solutions. But now let's move on to talk more about our today's topic, which of course is homogenizers. And these are the topics which I'll walk us through today. Firstly, a little bit of level setting as I talk about Homogenizer Basics and some of the language and terminology that we use. Then we look at the role of homogenizers specifically in dairy and some of the factors that influence homogenizer selection. Then I'll talk us through some innovations in energy and water saving and how to optimize the reliability and the longevity of your homogenizer. And as I said, then we'll take some questions at the end. Before we get into the detail itself, just showing here a general dairy process line, which includes all the usual elements that you'd expect: the storage, pasteurization, separation, heating, cooling, and here at the heart of it, you have homogenization, of course. This diagram is showing a UHT process, which is always using an homogenizer, but it could be a pasteurizer, it could be other kinds of dairy process as well. Homogenizers are usually at the center of this. So most of you will know what an homogenizer is, but it's worth being reminded of some of the basic principles and also the language which we use in describing an homogenizer. We talk about the power end and the liquid end of the machine. And that simply is the power end is the pumping part, and the liquid end is the homogenizing valve itself. You hear terms such as the block, the valves, and the plungers. And essentially what an homogenizer is a positive displacement pump, which delivers pressurized fluid to an homogenizing valve, and that valve assembly is designed for a specific application. The plunger pump itself typically has either 3 or 5 plungers driven by an electric motor through some sort of transmission, be it gears, but more usually V-belts feeding gears, and a crankcase. And it's that crank rotation which transmits the rotating power to the linear movement of the plungers and gives the pumping effect. Now, homogenization essentially is a physical process in which food and beverage process products go through some kind of shearing or hydrodynamic cavitation, and turbulence. Sometimes I think homogenization is misunderstood, and people think that perhaps there's something added or taken away to the homogenized product. And that's a misunderstanding. There's nothing added or taken away. It's the characteristics of the product that can change as it goes through the homogenizer. And that's the goal, really, to seek those characteristics which give some sort of improved product life or stability or taste or texture. So that's the power end of the homogenizer. Let's now take a look at the homogenizing valve itself. And here we see the homogenizing valve assembly, which is mounted usually on the front of the homogenizer. And what the pump does, it forces the product under pressure through a small gap in the valve. And we use terms such as the valve and the seat. It's in the homogenizing valve that the magic really happens. If you look at it on this illustration here on the right, the unhomogenized product, and that's designated as the larger bubbles, think of it maybe like fat, this enters the area of the homogenizing valve at a high pressure and low velocity. As it passes through this very tight gap in the homogenizing valve, there's a rapid increase in velocity and a decrease in pressure. And that release of energy causes intense turbulence and localized pressure difference, which sort of tears or disperses the particles apart. And that's the effect that you're looking for with homogenization. You're looking for some sort of a distribution and dispersion of the products. So there isn't a cutting or effect or things like that. It's really that impact and passing through the gap and the product impacting the other side of the homogenizing valve that causes the effects that we're looking for and achieves the benefits. Let's take a look more specifically at where homogenization benefits certain dairy products. And the key benefits throughout this list are consistency, stability, and ultimately that leads to a longer shelf life. And those products are predominantly achieved through excellent dispersion of fat particles when we talk about dairy. Now, for other products, it could be completely different characteristics, and I'll mention some of those as we go through the presentation. But to take some examples from this list, and some of them are very familiar to you, I expect. For pasteurized milk, regardless of whether it's UHT or high temperature, long shelf life, or just regular pasteurized milk, what you're looking for is to avoid creaming and to have a whiter, brighter color predominantly. And if you didn't homogenize the milk, you would have that cream line that you have on homogenized or traditional milks. It's what's desired by some customers, but the majority of customers are looking for a shelf-stable milk that doesn't have creaming after a few days. For milk that's going to be used for powder, so dried after processing, you're looking for a low amount of free fat, viscosity control, and no creaming after reconstitution as well. So again, it's that consistency of product output that we're looking for. And then for recombined milk, so this is after you recombine the powder, you're looking for stability. You don't want lumps, you don't want variation in viscosity or poor distribution and dispersion of fat. You're looking for a very consistent product. And the homogenized milk before drying gives you that result when the powder is then reconstituted. With yogurt, it's stability and avoiding whey separation. You get a better taste and texture the better homogenized the product is. And for ice cream, it's a slightly different effect. You're looking for ice cream which has a very fine structure, smaller air cells and smaller crystals. That leads to a smoother and more satisfying ice cream for the consumer. So again, homogenized milk leads to better water binding capacity and overall ice cream quality improvement. And with cheese milk, it's again stability, better texture. There's a lot of commonality between these characteristics, but the role of the homogenizer is essential, and the consistency of how the homogenizer operates is essential. That's why when we talk later about reliability, it's very critical that your homogenizer is working at optimal performance to avoid that you're getting variation in these characteristics. So now we'll look at the particle size with homogenization and how to control it. The particle size is really what drives the key benefits. As a rule, the smaller the particle size and the tighter distribution curve of the particle size, then that's driven by higher pressure of homogenization. So the particles in milk, you could imagine you have fat particles in unhomogenized milk, and the homogenization effect drives that smaller particle size and better distribution in terms of a tighter distribution curves. So pressure is the first one, and as a general rule, the higher pressure gives you a better homogenizing effect. But it is a trade-off, of course. The more pressure that you want, then you're paying for essentially in a direct way with more energy required to drive the motor and the pump to achieve the pressure in the homogenizing valve. So when we talk about energy saving later, it's very much related to the pressure that you need to apply. So the other parameters that affect the control of the particle size, the next one is whether it's a single or two-stage homogenizer. And that simply means how many homogenizing valves does the product pass through in series. The second stage is generally a much lower pressure, 10-20% of the first stage pressure. So if you talk about a 3000 psi homogenizer, you might run the second stage at 250 to 300 psi. And what the second stage does is it optimizes the effect of the first stage in terms of smoothing out any turbulence and cavitation and effectively acting like a back pressure buffer to avoid that, for example, you might have reagglomeration of fat particles if you didn't have a second stage on the homogenizer. So it's very much about securing the benefits that the first stage has achieved. That's the first additional factor. And then we have temperature. Homogenization of cold milk is really ineffective. You don't want the fat to be in an undissolved or any kind of solidified state, which it normally isn't, of course. But it's very important that milk is homogenized at a temperature where the fat is easily dispersed. And that's quite traditional practice going back many years, of course. There are other products where you want to minimize the temperature of homogenization. For example, in the pharmaceutical sector, some products are detrimentally affected if you have higher temperature during and after homogenization. So in those situations, you try to do it at the lowest temperature possible. One standard outcome of homogenization, of course, is that as you homogenize and as the product passes through the energy zone of the homogenizing valve, then there is a slight temperature increase. That's quite common. And in the dairy sector, it's not a bad thing because you can use that heat generated as part of your thermal process. So the next factor here on the list is the homogenizing valve type. We could spend a whole webinar talking about homogenizing valves. When you think about the geometry, the size, the angles, the materials of construction, all of these factors are carefully selected to match your duty. For example, when you think about materials of construction, we use harder materials such as tungsten carbide or ceramic when a product is going to have some kind of abrasives or very high pressure. And in the dairy industry, this might be, for example, if you have flavored milk with cocoa particles to create a chocolate milk. So the homogenizing valve type and material is critical for a successful long-term operation. And then the premix properties. So it's sometimes said that the homogenization is as good as the quality of the product coming in. And for regular milk, that's straightforward, of course. It's coming in directly from the incoming milk, perhaps being standardized to a certain fat content. But it's always best for the premix to be effectively homogeneous as well. If there are any ingredients added, that they should be evenly distributed. The homogenizer isn't a mixer, so it's very important that whatever characteristic ingredients that you have, that they're evenly distributed through the feed. And also with particle size distribution, it's going to homogenize best if the incoming particles are as stable and consistent as possible. So techniques that people use, for example, are using inline mixers or in some cases shear pumps or other devices to make sure that the feedstock for the homogenizer is as stable as possible. And the thing that must be avoided in the premix, and indeed for homogenizers in general, is any air. coming into the suction side of the homogenizer. That really can cause problems with the operation of the homogenizer, with severe cavitation, and in some cases you'll end up with some damaged parts. So great care must be taken that tanks are not emptied below the minimum, and that there's always a positive feed pressure into the homogenizer. And finally, the number of passes. This isn't really so relevant for the dairy industry, but in many industries, we will homogenize multiple times to get an increase in the reduction of particle size and particle size distribution in a tighter curve. So these are some of the factors to control particle size in the homogenizer. And now we'll take a look at some of the wider parameters when selecting or optimizing your homogenizer. So these are some that are required for selection of the homogenizer, or indeed to bear in mind if you change your product or your recipe, or you're doing something different, be it a new pressure, temperature, or a new product feed. It's always worth checking these with your application specialist. For example, if you're adding a product with some kind of flavor, you might want to check the materials, as I mentioned before, for the homogenizing valve. But of course, if you're asking what do we need to know to select or to check an homogenizer? Of course, it's the product and the application. The flow rate and pressure are critical, and they really determine how big the homogenizer needs to be, how big the power requirement is. The temperature can be important. It can be an homogenizer or a high pressure pump, or indeed it can be both. For example, if you're using your homogenizer to feed a spray dryer, in some cases you're just pumping to the spray dryer, in some cases you're pumping and homogenizing. We can ask about 1 or 2 stages, and we can always recommend which number of stages are best. And in a critical parameter, if you're asking about a new homogenizer, is it fixed or variable flow? Traditionally, most homogenizers were fixed flow, they had a fixed output, but more and more our customers are expecting that we have a variable flow. So then you can vary the throughput to match specific situations like filler speed or the capacity and availability of downstream tanks and storage. It's worth remembering, though, when it comes to variable flow, that as the homogenizing valves are selected for very precise process parameters, you can't always have the same homogenizing effect in terms of that good particle size distribution at each flow rate. So if you can imagine 100% flow could be your optimum setting. Well, as you turn down the flow and you get below 50%, very often you're going to compromise in your homogenizing effect. So where you have a process that requires different flows, it's worth thinking about where's the one that you're going to be running the most. Is it 100%, 75%, 50, whatever? And then you can talk to your application specialist about making sure that your homogenizer is optimized for that flow. And then the next factor is the type of control. Traditionally, often operated manually and locally with the homogenizer, but of course, with increased automation, most homogenizers nowadays are sold with semi-automatic or fully automatic controls. But talk to your supplier and your specialist about whether you want those controls to be controlled from your central system, or whether you want it locally to the homogenizer with a communication to your central control system. All sorts of options are available depending on your control philosophy. And then, of course, power supply, depending on where you are in the world, you may have different voltage and frequency or other specific requirements. For example, very often when people are replacing existing homogenizers, they will have a floor space limitation or access requirements to get into the room. And then we can look at selecting an homogenizer shape and geometry that best suits the requirement. So that's it on how to select and choose the best homogenizer. Now I'd like to take us through some innovations and improvements can be made, either when you're selecting new homogenizers or when you're thinking about upgrades for your existing homogenizer. So the first one that I want to talk about is saving energy. And this features our microgap valve, which is a patented APV technology, which has been around for a number of years. And the headline here is that you can save up to 25% energy by reducing the homogenizing pressure with no impact on the product parameters. If you remember, I mentioned that pressure is directly related to energy. So what this valve allows us to do is to offer a lower energy solution by using the homogenizing valve geometry differently. I'll talk through the benefits first, and then I can show you on the next page how this works. So first of all, the benefit is it's an energy saving. The pressure can be reduced by up to 25%. And what does that mean? As well as the actual operational cost saving by using less energy, then there's an investment saving potentially, because if you're looking at a new homogenizer, we may well be able to fit a smaller homogenizer to do the job. Certainly the motor can be smaller, but sometimes we can actually go down a size of homogenizer as well. The improved homogenizing efficiency that you get with this type of valve, if you don't necessarily need the energy saving, what you can do is you can apply the microgap valve to your existing pressure and achieve a better efficiency, a better product in terms of the particle size and the particle size distribution. So effectively, you can get two benefits: either reduced pressure and reduced energy consumption, or at the same pressure and energy consumption, you can get a much higher homogenizing effect measured in terms of efficiency and particle size distribution. You can also process very high flow rates at high efficiency, which is one of the limitations of traditional homogenizing valves. It's also compatible with partial homogenization techniques, which is another great way of reducing energy for milk processing, and variable flow. And with these valves, there is a limit. We can't use these valves at our lower flow rates. So the flow starts at around 1,600 gallons an hour and pressures up to 4,300 psi. These microgap valves are available on new homogenizers, but also can be usually retrofitted on your existing homogenizers as well. So talk to us if that's something that you would like to explore. Just to show you a little more detail about how these microgap valves work. Effectively, it's changing the geometry of how a traditional homogenizing valve operates. Just focusing on the words here first. A conventional homogenizing valve is a single flow path where one valve and the fluid are operating together in one flow. And there's a small controllable gap which all the fluid goes through. A microgap valve is effectively a set of multiple valves which are stacked in a single housing. Here you see two views. This is the cut through and this is the cut through showing the liquid. And just showing it here on the left first, the liquid comes in here at the bottom and then it passes through multiple flow paths of discs and then exits here at the top. And because of these multiple disc paths, the homogenizing efficiency is extremely efficient and achieves a very high level of homogenization at a lower pressure. I talked about one or two stages before. The microgap valve has a very straightforward back pressure second stage, just to give that final stabilization and avoid reagglomeration that I've mentioned. So the result of all of this is you get a really high efficiency valve. You might think that the discs, which might appear less robust than a traditional homogenizing valve, you might think that they had a shorter service life. But in fact, they're made from extremely high quality stellite or tungsten carbide materials, and they have an extremely long operating life, which doesn't compromise the reliability compared to traditional valves. And in terms of operation of the controls and the cleaning, it's exactly the same as a conventional homogenizing valve. You simply take off the homogenizing pressure, and that enables you to clean it in the normal way, and then the flow path just goes through for cleaning in the same way as production. So have a word with your representative if you'd like to know more about these microgap valves. They're extremely well proven in the field, and especially with energy costs rising, it might be worth taking a fresh look at this. So now let's move on to water saving. Why save water? And there are a number of ways which I'll take you through to save water on your homogenizer, but we talk about saving water locally at the homogenizer rather than through some sort of central collection and treatment system. Well, firstly, water costs are increasing, and water consumption is traditionally considered as taken for granted, perhaps in dairies in particular. Homogenizers use a surprising amount of water for cooling and lubrication, and that water is often process quality water, and it's often used just once before it goes down the drain. Large-scale wastewater and collection treatment is complex. So what we're trying to do with these techniques that we'll show you is capture that water before it goes down the drain. So therefore you optimize your chance of reusing it, reducing it, and in the case of the water system, recycling it as well. So two things that we'll talk through. One is our Homogenizer Water Recycling System, or HWRS, and then perhaps a smaller incremental improvement. It's about upgrading to serial lubrication of your homogenizer plungers. Before we get into that, just to share with you some of the numbers around what the water consumption can be in an homogenizer. Very often this is a hidden consumer of water because it's taken for granted or it's always been like that. But here's some examples based on two scenarios of consumption on the right, 10 hours a day or 20 hours a day. Very often, of course, you're running more or less continually 5-6 days a week. And so for one homogenizer, from medium to extra large, could be consuming anywhere between 500,000 and almost 2 million gallons of water a year, which is a tremendous amount of water to think about optimizing or reducing in some way. We find that older homogenizers tend to use more water than some of the newer ones, which have more advanced controls in terms of water consumption. And generally what you'll find is that the water consumption in an actual plant situation can be higher than the nominal water. It's because people naturally tend to leave that valve cranked open a little bit more just to make sure that there's no overheating or anything running dry. But of course, that little bit more on the water valve can often mean that you're consuming a lot more water than necessary. So the first thing that talk about for saving water is our Homogenizer Water Recycling System, or HWRS. And this is a closed loop recycling system which is designed to save up to 97% of the water in an homogenizer. This is operated in this way. We'll show a schematic in a moment, but here we have the key characteristics of how it works. Firstly, it's a plug-and-play system with these two little skids which you see on the picture, and they integrate right into the homogenizer water supply and return. The 97% recycling is based on the other 3% being used for startup and certain recirculation routines and back flushes during the operating day. It's fully automatic with a simple user interface, which can be integrated to new and existing homogenizers. And the water quality that's recycled is certified to PMO standard for process use. So it's fully accepted within the industry. It can be applied to any homogenizer, not just APV models. It's designed to retrofit on any. And the water is captured locally and recycled before going into the drain. So that's why we've tried to, as I say, keep the water from going down the drain where the further processing is more challenging. Just to show you how the system is configured, here you see the typical homogenizer. And there's two, if we take the water coming out, there's two water consumption points. There's the oil transmission cooling, and there's also the plunger lubrication water. Now, in many older homogenizers, the two were piped together in series, but you won't generally find that on any new homogenizers. Those water streams are collected in this tank skid here, where it's screened and water quality is checked. And if the water falls below certain parameters, then it's immediately exited to drain, and we don't attempt to recycle the water. So that could be, for example, if there had been some kind of leak, as in the plunger packings. But assuming the water is within tolerance and it's relatively clean, then it's pumped back to the sanitation skid. And in the sanitation skid, we filter, we sanitize, and we cool the water so that it's ready to flow back into the duties of the homogenizer itself. The sanitation skid is also where the inbuilt PLC's controls are, and this has the alarms and control sequences and the communication back to the plant control system. Now, people always ask, well, what happens if there's some sort of an issue with the sanitation skid or it goes out of service? And the system is equipped with fail-safe connections to the process water supply. So no matter what happens, there's a guaranteed flow of water through the sanitation skid to the homogenizer in the event that it can't recycle. So there's never going to be an interruption to your homogenizer operation because of the HWRS system. Just want to remind of some of the benefits that we showed on the system. I won't go through all of these, but the most important benefit is that it's recycling 97% of your water required by the homogenizer. So thinking back to your 500,000 gallons of water per year on one homogenizer, that's a huge potential. It's a cost saving immediately, but it's also sort of insulation against future water cost increases. And then the other benefit is it's process quality water. This water that it recycles meets or exceeds the PMO standards, and it's 3A approved. Also, you don't have any interruptions to your supply as mentioned, so you do get that fail-safe and redundant control. One thing which this system does, which you won't get on any traditional or simple water systems, is effectively it's a built-in leak detection and water quality monitoring system. Because of the instrumentation on board, we know immediately if there's a packing leak or something which is putting the water out of spec, and then it creates the alarm. And of course, it's controlling the water temperature as well, bringing it back up or down, up for the lubrication water or down to the cooling water temperature for the transmission cooling. And finally, it's a plug-and-play system to fit APV and other brand homogenizers. So talk to us if you have concerns about your water consumption, if you'd like to try out one of these systems to reduce your water consumption considerably. As mentioned, it fits any brand homogenizer. So that's our HWRS system. The next is about plunger lubrication water saving. So this could be an incremental improvement, either with or on the way to a bigger investment, such as the homogenizer water recycling system. The simple solution here is to upgrade your plunger water to serial lubrication by putting the water to the plungers in series rather than the traditional parallel flow. And serial lubrication offers you the opportunity to reduce your plunger water consumption by 2/3. Effectively, the same water is lubricating each plunger, and then it exits. There's also an energy saving when you think about, in many cases, the plunger water is heated up to be somewhere close to the process temperature, then you're heating less water up. And this technique can be applied on all new machines, except some of the very smallest sizes, and as an upgrade on existing machines. So please talk to us if that could be of interest. The upgrades vary in complexity, but in most cases it can be done with some simple piping and new glands and seals. It's a nice way of making a quick change to reduce your water consumption. And finally, in terms of how to make the most of your homogenizer operation, we talk about reliability. And there's some factors that we would always recommend to ensure the optimum reliability of your homogenizer. The first one, of course, is use original OEM parts. These are designed to keep your homogenizer running for as long as possible. And in the APV world, particularly with our Golden homogenizers, we have some fantastic homogenizers, examples of homogenizers, which have been running for many, many years. Also using original parts ensures that you get compliant seals, elastomers, and packings. Think about the training. Have your operators and service personnel been trained in understanding and running the homogenizer properly and taking care of it service-wise? Talk to your distributor or partner about training and improving knowledge if you want to ensure that your homogenizer runs at its best for as long as possible. And of course, the goal is avoiding unplanned maintenance and downtime. So we would always recommend planned preventative maintenance with homogenizers to make sure that they run successfully for as long as possible. And talk to our representatives about aftermarket support agreements, for example, service level agreements or parts level agreements. These are designed to make sure that your homogenizer is taken care of, and indeed your other process equipment as well. So really, reliability is about how well you take care of your homogenizer, and our customers know that when we take care of the equipment and look after it, then it has a very long operating cycle. Homogenizers are around to operate for a very long time. And many of the upgrades that I mentioned, whether it's the water recycling, whether it's the microgap valve, whether it's the serial lubrication, they can usually be applied even on some of the very much older homogenizers that are operating in the plants around the States. So that's the end of the presentation portion. As you're aware, probably this is a series of 4 webinars, and the additional topics were valves, pumps, and UHT. In the communication material, you can find links to all of the events, even the ones that have already taken place. So if it's of interest, please click through and try to find them if you'd like to learn more. And now this ends the presentation portion for today. I'll begin our question and answer session in a moment. And as a quick note, after the webinar, we will invite you to take part in a questionnaire and you'll receive a copy of the presentation. I'd encourage you to post your questions here or contact me directly, and then we'll do our best to answer the questions. So let me just take a moment to look at the questions here and we'll go through them. Thank you.
Okay, thank you for listening and submitting the questions. So I've got a good number here. If I don't get to all of them, and I may not get to, then I'll reach out to you directly to respond. But let's get started. So the first one is around the hygienic and sanitary design principles that we use on our SPX APV homogenizers. So predominantly, we're using design standards like 3A for the sanitary design. That covers the product contact surfaces. And then we also apply principles of good sanitary practice on the frames and on the internal areas. For example, no penetrations through the olive frames, things like that. When it comes then to the materials that are selected, particularly the seals, well, we're governed by the application. So for example, if it's a food application, then we're looking at the FDA requirements. But we've got to balance that with the longevity of the parts, the pressures needed. So we use things like U-rings and V-rings for plunger packings at regular pressures, and then things like braided packings at higher pressures. But we're always governed by the application, which then drives the regulatory framework. Plus, obviously, everybody wants their soft parts, particularly, to last as long as possible. So thank you. That was a good question. Then we've got some here around the energy saving valve, the microgap. Have we taken into consideration the cost of refurbishment or replacement valve cost? So yes and no. The headline 25% energy saving is basically the energy we can save by operating at a lower homogenizing pressure. So that can influence the OPEX in general from an energy point of view, but also the capital, because if you're buying a new homogenizer, very often you can select a smaller motor. You can go down one size, horsepower size, or you can select a smaller model in some cases. So that's where it becomes important for a new machine. When we look at aftermarket upgrades, then of course the replacement parts, and whether it's refurbishment or replacement comes into it. There we've done some ROI analysis, which of course is highly dependent on your operating hours and your energy rate. And the microgap shows very favorably in terms of how quickly it pays for itself as an upgrade option. So thank you for that question. Question around CIP. What flow rate do we recommend for the best cleaning? So the basic answer to that is really to be governed by the pipe size. You'll apply your typical plastic design standards of something like 5 feet a second for cleaning the line. Very often the homogenizer will be operating at a lower flow rate than that. But what you find is that homogenizers, as long as they're able to receive the flow rate that they process, will clean themselves correctly. You may need to have a bypass line around the homogenizer in many circumstances to ensure that your upstream and downstream lines are getting the correct flow rate. And all you do during CIP is you run the homogenizer at a slightly slow speed, just to make sure that everything is moving, everything is getting cleaned. You typically unload the pressure to a very low level, and then you can get make sure that there is some back pressure so that all the surfaces are cleaned properly. But it's pretty standard practice. So when some of the questions here around talking about water saving and the cooling system, do we have any systems in place to figure out when customers are using too much cooling water and they don't even know it? So that's a great question. And we do have systems in place predominantly around making sure that there is water there. So like flow switches, and obviously you get a secondary control measure because your oil temperature will increase if there isn't enough cooling water. But that's something that we have been looking at on newer models in terms of not a flow switch which says yes or no, but a flow transmitter which will tell you exactly how much flow is there. And then we can take a higher flow alarm, a low flow alarm, and warn the customer that they could turn it back a little bit. So that's something that we will probably be offering as an upgrade as well. Pretty low cost upgrade to help optimize your water use before going to those other investments. Then a question related to the HWRS, or a number of questions. So are there other applications other than the dairy or food industry? Well, technically you can use it wherever an homogenizer is used, and also, in fact, wherever water is used. So some cases you have pulp seals or mixer seals, double mechanical seals, where we've picked up on the water because it was local to the homogenizer. Really, it depends on how much water and the level of potential fouling in the water that could prevent it from being recycled. So have a word with us and we can take a look at any application. And there's a related question I see here. How do we determine the level of solids coming out of the plunger cooling water? And I guess the question relates to what happens if there's a leak of plunger packings. Well, we're using a combination of turbidity and total dissolved solids to do that initial screening of the water. So that way we can have a baseline measure. We know what the system can sanitize out and filter out. And if there is an extensive leak, then we can divert the water to drain before we even try to recycle it. So that's where the screening in the tank skid performs the initial assessment. A couple of more questions on the HWRS. What sanitizing process do we use? Is it chemical or physical? Well, it's essentially a physical in the sense that it's filters and ultraviolet light sanitation. I think that's a great question, Sarah. As I say, I may not get to all of them, but I'll take a couple of more. Is the HWRS available for trials? Absolutely it is. Please contact us and we'd be very happy to have you tested out at your facility. Question relating to the footprint, which we can answer afterwards, is also available on the website. I do have another one here in terms of what happens if you have a two-stage homogenizer and you swap the stages around. So generally, homogenizers work best where the second stage is at a much lower pressure than the first. We do have situations where people do it the other way around or have them equal, but what you can run into is some control problems with the second stage. So the units are set up that you can try it. There's generally no limits on the second stage, but you may find some instability in the controls. So then we have another question here around what's the testing for the HWRS? Yes, as I said, we can send it to your facility to test. That's always the best way to do it. We're very happy for you to take a look at one and try it out yourselves. Okay, there are a couple of more questions, but I'm conscious we've reached the top of the meeting. So what I will do is get back in touch with you directly afterwards. Really grateful for your active participation, and I hope you found the presentation useful. My contact details are available. Don't hesitate to get in touch with myself or any of my colleagues that you know. And with that up, I think we'll wrap it up for today, and thank you for your participation.